Hello everyone, welcome back to my YouTube channel Unfog with Dr. Atahar Parveen. In this lecture, we shall discuss all about basic concepts of chemistry. Basically, according to your HSTR syllabus, the first chapter of chemistry. That is, including molarity, molality, mole fraction, mass percentage and few numericals based on that. So this is what your portion is. The syllabus of HSTR basically. Even kries, you can say that the general syllabus of this is included in kries also. Now, this is very important topic because see, at least one numerical comes from these topics usually, okay? And the numerical problems, they are very simple. Only thing is that you should just have clarity on the concepts like this molarity, molality, mole fraction and mass percentage, okay? Now, let us start with molarity. Now, to discuss what is molarity, first we have to recall what is a mole. Mole means it is the amount of any substance that contains 6.022 into 10 raised to 23 particles. This 6.023 into 10 raised to 23, it's a definite number and it is known as Avogadro constant or commonly also known as Avogadro's number. If you had been a GPSTR aspirant as well and if you have attended my GPSTR chemistry classes, then you should be knowing that how much important this Avogadro number is. Whenever this mole concept comes in our mind, we need to use the Avogadro's number. So basically, 1 mole of a substance is equal to 6.022 into 10 raised to 23 particles of that substance only. Now let's talk about molarity. Molarity means it is the number of moles of solute per liter of the solution, or it is the ratio of number of moles of solute to the volume of solution in liter. Molarity, it is equal to number of moles of solute upon volume of solution. Now this solution is in liters. Now what is this solute? See, for example, if you mix sugar in water, you get some liquid, right? That liquid is called solution. Here this sugar is there, no? It is known as solute. The particle which you have dissolved in water, it is called solute. And this water, it becomes solvent. Okay? The one which is allowing the solute to dissolve in it is called solvent. So you can remember this, right? If you have water and you are dissolving some sugar in that water, then you are getting one solution. In that solution, the sugar is known as solute and that water is known as solvent. So if you remember this example, then you can remember these three words also. This is the best trick to remember these things. Now, we know that molarity is equal to number of moles of solute upon volume of solution in liters. Now, what is this number of moles of solute? Number of moles means the density, right? The density of that material. Density is equal to mass into volume. And this molarity, it is denoted by capital M. Commonly, we denote it by capital M. Now, if you are still not getting what I am trying to say about molarity, I will give you one more example. Let us understand it this way. See, if we say that molarity of H plus ions is 3m. That means I am saying that 3 moles of H plus ions are present in 1 liter of solution. Okay. When I say that molarity of H plus ions is 3m, I say that 3 moles of H plus ions are present in 1 liter of solution. Okay. Now this was all about one solute and one solvent. How will you find the molarity if you have more than one solutes and more than one solvent? That I'll explain you with this example. See, for example, if you have two solutions of a substance, they are mixed in the following manner. 140 milliliter of 1.5 m first solution plus 520 milliliter of 1.2 m is second solution. They are mixed together. Now you have to find the molarity of the final mixture. In this case, what you do? See, what was the molarity? Molarity was equal to number of moles of solute upon volume of solution, isn't it? Number of moles of solute upon volume of solution, and this was in liters, right? This was for one solution and one solute, right? If you have many, then what you do? Then you can use the subscripts. You write in place of mv, you write m1 v1 plus m2 v2 plus m3 v3 and so on. Okay? And then in the denominator, what you will have? You will have v1 plus v2 plus v3 plus you don't know how many are there solutions, so many you can write. Okay? So this is one way of finding the molarity for a mixture. Now we can find the final mixture molarity here. Very easily we can find it. See, m for final mixture, it will be equal to, here we have one mixture with two solutes and two solvents, right? So I will write as m1 v1, which is the density, mass into volume, plus m2 v2 upon v1 plus v2. Now m1 will be 1.5, isn't it? So this will be m1. m2 will be 1.2. This will be m2. Then volume, v1 will be 480 ml and v2 will be 520 ml. Now just you substitute the values here. m1 will be 1.5 into v1 will be 480. We don't need to change any units here because both the values are in milliliter, right? Then m2 will be 1.2 and v2 will be 520 upon v1 is 480, v2 will be 520. This one will be equal to around 720 plus 624 upon this one will give you 1000 or 1344 upon 1000. You can see the options here. If you see the options, you will get to know that 1.344. I have to remove the 1000 and put the decimal place here. M. This will be the molarity of the final mixture. So option 2 will be the right answer. Okay. Now there is one more very common question which can be asked based on this molarity. With increase in temperature, which of these changes? Molality, fraction of solute present in water, molarity, mole fraction. So still we have not discussed this molality and mole fraction. We will discuss this in this lecture only. But here just for your knowledge, I am telling that molarity is dependent on volume, right? Number of moles will be there in the numerator and in the denominator you will have volume. This volume, it is dependent on temperature, right? If you change the temperature, volume may change. That's why molarity is the right option here. So you have to remember that temperature will affect the volume of solution. Hence the expression for concentration that contain volume will change the temperature and that expression is the molarity. Okay. Now let's talk about what is called molality. We talked about molarity. Now it is molality. It is the number of moles of the solute per kilogram of the solvent. Basically, it is the ratio of number of moles of solute to the mass of solvent in kg. See, this now symbol will be small m for molality. For molarity, we told that number of moles of solute upon volume of solution in liters. Okay. But for molality, molality is equal to number of moles of solute upon, there we were talking about volume of solution, right? Now we talk about mass of solvent. This will be solute in numerator, there will be solvent in denominator, and this solvent will be in kgs. Okay. Here in numerator it is same. Number of moles of solute means you will use mass into velocity only. That is only density. But in the denominator, you will just use the mass of the solvent. Okay. This you have to remember. You don't get confused between the formulae for molarity and molality. In the denominator, for molarity, you have volume of solution in liters. In molality, you have mass of solvent in kg. Okay. Now, this type of a question may be asked. Which of the following is the correct formula for molality? Here you should not get confused. Molality is equal to number of moles of solute upon mass of solvent. See here where you have mass of solvent in the denominator, you have only in option 2. Now you see the numerator, moles of solute. Yes, this should be molality. Option 2 should be the right answer. Next, they can also ask this type of a question and they give you 4 options. Okay. I think this question, kries people should focus on these type of questions. The question is, what is the molality of a 3.75 m H2SO4 solution with a density of 1.30 gram per milliliter? See here, they have given you one sulfuric acid solution with density. Now you have to find the molality of this solution. What you do first? First you find the mass of 1 liter of solution. What will be the mass of 1 liter of solution here? For this you have to multiply the density with 1000 ml. You get the mass. It will be 1230 grams. Now you find the mass of sulfuric acid. 3.75 mole of sulfuric acid. For this what you do? You multiply 3.75 with the molecular weight of H2SO4 or the molar mass of H2SO4. How you calculate the molar mass of H2SO4? See, for hydrogen, atomic mass is 1 and you have 2 atoms here, right? So it will be 2. Then again for sulfur, atomic mass is 32. We have only 1 atom here. So it will be 32. Then for oxygen, atomic mass is 16. You have 4 atoms here. So multiply it with 4. You get 64. Now add all these. You get around 98. Okay. I am not using the decimals here to make things easy. Okay. So let's just assume that it is 98. It is a round figure. It's an approx number. So you just multiply this 98 with 3.75. Then you get the mass of 3.75 mole of H2SO4. Okay. It will be around 367 grams. Now you find the mass of solvent. Mass of solvent will be equal to the mass of solution minus mass of solute. Now 1230 minus 367. It will be around 862.2 grams. Okay. Now this mass of solvent, it is in grams, right? But we need to have it in kg. So you convert it in kg. How you convert it? 862 upon 1000 or 0.862 kg. Now you can easily find the molality. Molality is equal to number of moles of solute upon mass of solvent in kg. Number of moles of solute is 3.75 moles. It is given in the question. Divided by 0.862 kg. You will get 4.35 m. This will be your molality. Okay. So this, I think kries people should focus on this type of sums. Now let's talk about what is called mole fraction. Mole fraction means it is the ratio of number of moles of a particular component to the total number of moles of all the components in that mixture. It is usually denoted by xi. Some people also write it as xa also. So basically this mole fraction, it is also known as molar fraction. Now if I want to tell it in simple words, this mole fraction, it is equal to moles of solvent upon total number of moles of solution. Moles of solvent upon total number of moles of solution. So moles of solvent, I can write it as, see here, this mole fraction, it is denoted by Xi. Now moles of solvent, I can write it as Ni maybe. And total number of moles means I will write it as N total. See, the word fraction only tells you that if you add all the fractions, you will get 1, right? So sum of all mole fractions will be equal to 1. This is a very important point here. Sum of all mole fractions will be equal to 1. Now, if I have to add many fractions in that mixture, see, if I take summation Ni, then I start from I is equal to 1 to N. I write it as N total. Then if I take summation for Xi, I will start I is equal to 1 to N. I will write it as Xi. This will be equal to 1. How did I get this Xi is equal to 1? Then see, if I take summation here, let me use this formula again. For Xi, if I take summation in the numerator, I will write it as N total only, right? Then again I have N total in the denominator. Both will get cancelled and I will get summation Xi. This will be equal to 1. This is a very important point you have to remember for mole fraction. Now let's see few MCQs which may be asked. See, these are very important MCQs. I have done lot of research and I have picked this few questions for you all. So if you just watch this video, this topic, it is like you have prepared fully. Okay. So this type of a question can be asked. What is the mole fraction of sodium with moles N in a solution with moles of solvent capital N? Here in place of Ni, they have given N. In place of capital N only is there. What they are telling? You have to find the mole fraction. Now what is mole fraction? Mole fraction is equal to moles of solvent upon total number of moles of solution. Just now we have written it, right? Xi is equal to N upon small n plus capital N. Because we are talking about N total, right? N total will be equal to small n plus capital N. So your option C should be the right answer. Now next question. This is a similar question like the above one. But here they have given you numbers and they want you to find the capital N. See, the question is if the mole fraction of 4.5 moles of solute is 0.5. What is the number of moles of solvent? Here 0.5 is the mole fraction given. So this is Xi. And then 4.5 moles is given. This will be your small n. Here you have to find capital N. Now you know that Xi is equal to small n upon small n plus capital N. Xi is given as 0.5. This will be equal to small n is 4.5 upon 4.5 plus n. Now you can easily find n, right? So 4.5 plus n will be equal to 4.5 upon 0.5 or 4.5 plus n is equal to 5 ones are 5 nines are. So this will be equal to n. N will be equal to 9 minus 4.5 or n will be equal to 4.5. So option B will be the right answer. So here you have to read question carefully and then you have to decide what are the values given and what are the values you have to find. Okay. Next question. This type of a simple question can also be asked in your HSTR examination. What is the unit of mole fraction? See, for a mole fraction, the formula is moles of solvent upon total number of moles of solution. So you have moles in the numerator and then moles in the denominator. So you will not have any unit. Okay. So what is the unit for mole fraction means? Here D, it will be no unit. So option D will be the right answer. Okay. Next example. If in a compound the moles of consisting atoms are doubled, then the mole fraction of a particular atom will be. See, for a mole fraction, if you are increasing the number of moles in the compound, here especially you are making it double, then mole fraction also will become double, right? Because see, you have number of moles of solvent in the numerator, you have total number of moles of solution in the denominator, nothing is going to decrease here. So if you are doubling the number of moles in the compound, then mole fraction also will be double. Okay. Next question. A gaseous mixture contains 4 gases. A, B, C and D, the mole fraction of B is 0.5. The mole fraction of A will be, there are 4 gases, right? A, B, C, D. In this one gas mole fraction they are given. See what I told you for mole fraction, very important point it was, right? It is sum of mole fractions is equal to 1. That means what all gases they are given here, the sum of the mole fraction of these gases will be equal to 1. Now for simplicity, let's say that the mole fraction of A will be XA, mole fraction of B will be XB, mole fraction of C will be XC and mole fraction of D will be XD. Now if you add them, that means if you take sum of these, you should get 1, right? XC plus XD, this should be equal to 1. In this they have given 1 mole fraction. They have given 1 mole fraction for XB. So your XA plus XC plus XD should be equal to 0.5. That means here the mole fraction of individual gases will be less than 0.5. Means for XA it will be less than 0.5, for XC it will be less than 0.5 and for XD it will be less than 0.5. In your options there is one option which is less than 0.5, right? Not only the mole fraction of A but the mole fraction of C and D individually will be less than 0.5. So option B should be the right answer. See, this was a very interesting question, right? In many questions, you don't need to arrive at your final answer. At half of your answer only, you can judge the right answer and take the right answer. Okay? Now, let's talk about what is called as mass percentage. Now, this is another way of representing concentration of an element in any compound or a component of a mixture. How you calculate it? You calculate it as the mass of a component divided by total mass of mixture. Then you multiply it with 100. This is one way. Or the another way to find the mass percentage is equal to mass of solute upon mass of solution. With this you multiply 100 now because you are finding percentage, right? Whenever you find percentage, you have to multiply it with 100. This mass percentage, in some books they represent it like this, M upon M, or they represent it like this, W upon W. This W means weight, M means mass. Okay. See, this type of a question may be asked. Mass by mass percentage of a solution is, so just now I told you, right? Mass by mass percentage of a solution will be mass of solute upon mass of solution into 100. So it will be option A. Now this type of a question may also be asked and they may give you 4 options. You have to take the right one. The question is, an aqueous solution of calcium chloride is prepared. Determine the mass by mass percentage, that is 5% solution of calcium chloride that can be prepared using 100 grams of calcium chloride. So what you do here? Now you know that the mass by mass percentage of solution is equal to mass of solute by mass of solution. This you multiply it with 100. They have given you mass of solute which is 100, right? 100 gram of calcium chloride is there. And for solution they have given you 5% of solution. Multiply it with 100. 5 ones are 5 20s are. This will be equal to 20 into 100 gram solution, or 2 into 10 raised to 3 gram solution. Whatever is there in your option, that you can take. Okay. Now let's have a very quick summary. Molarity means number of moles of solute upon volume of solution in liters. Molality means number of moles of solute upon mass of solvent in kg. Mole fraction means number of moles of solute upon total number of moles, or number of moles of solvent upon total number of moles. Then at last mass percentage. This is equal to mass solute upon total mass into 100, or mass of solute upon mass of solution into 100. Okay. So here I will write it like this for you. This is equal to, either you can write this formula or you write it as mass of solute upon mass of solution into 100. For mole fraction in place of solute, you can write solvent also. Whatever is required, you can use that formula. Okay. So this was all about basic concepts of chemistry: molarity, molality, mole fraction and mass percentage. Whatever numericals I have discussed here, they are more than enough for your preparation. Okay friends. If you like my work, please do like, share and subscribe to my channel, and keep working hard. All the best. Bye.